Okay, we are going into chapter 6.2 now. This is the second video you're supposed to watch over the holiday break and get that homework completed to us and done. This is more of the stuff that you'll be more comfortable and familiar with, the stuff that you've learned previously in 7th, 8th, 9th grade that you'll be able to do, I think, with no problem at all. Real quick, one thing I would like to know is a little feedback on whether you like this particular method where I'm using this particular app to create the videos, or if you like just the app that I was using before, or the notes that I was using before, where I was just going through and clicking the different things. I feel like on this particular app that you can get more in-depth information and actually see the work go as it's gone, rather than just kind of showing you some of the computer problems. So just leave me a little message on YouTube, kind of a comment, just letting me know if you prefer this style of video over the ones that we have been using in the past that are just coming directly from the notes, and I just kind of uncover the answers and stuff. Alright, so let's go ahead and just jump in and get started. So we're going to use proportions to solve geometry problems. Again, I apologize for the handwriting. Handwriting's not great on this, but that's because of the stylus that I have to use. But in any case, this is stuff that you should be familiar with, and it's basically set up like what you see here. If you have A over B, and it equals C over D, then no matter what, this A and B should be a pair and the C and D should be a pair. So if I flip this, going here to this part, I now have B over A. So if I switched A and B, essentially, okay, and I got B over A, okay, what should the next side be? Yeah, that's right, D should be on top and C should be on the bottom. They kind of stay together. If I add the denominator to the numerator, so I have A plus B now over B, then on the other side I should also add the denominator to the numerator there, so now I have C plus D over D. Now I know it looks and seems kind of confusing just hearing me talk about it, but you'll understand when we start putting figures to it. But essentially, these are, because of this equal sign right here, these are equivalent. And it's almost like any kind of an equation. What you do to one side, you must do to the other. So if I flip this side, then I have to flip this side. Okay. If I add the denominator to this side, I must add the denominator to this side as well. All right. So let's just break right into this. All right. So if we have it's 8 over x is equal to 3 over y. Then if we took 8 and 3 together, so essentially we took the numerators and we put the 8 on top of the 3, what do you think needs to be the other side of this equal sign? Yeah, you'd be correct if you said x over y. That'd be absolutely correct. It's all about the order in which you put these in. That's the big key here, is making sure you pay attention to the order. Here I took the two tops, and I took the top on the right and put it on the bottom, okay, below the top on the left. So then I'm going to take the left and put it on top of the one on the right. Again, that just sounds more complicated than it really is. Okay? So if we look at this figure over here, we have a triangle and we see our median, or whatever you want to call it there. If we know that AB goes over BC, what do you think the other side of this equal sign should be? Yeah, AE over ED. Okay, just keeping the same order. So here we have the top part over this, and that means on the other side we need to have this part over this, right? Pretty simple. Now if we use the same problem, and now we have AB plus BC, so AB plus BC, okay, over BC, what do you think the other side is going to look like? Yeah, AE plus ED over ED. So especially if you compare these two together, all we did was add the denominator to the numerator on both sides. Add the denominator to the numerator here. So basically we put plus BC over here and plus ED over there. Now that's not really solving any problems, it's kind of setting those things up for us, but if I wanted to solve a problem, I could look at solving a problem that looks like this. If I have AB, which is x, okay, so if I take that AB, which is x, and I put it over BC and the actual value of BC, which is 6, I can set it equal to AE, which is 4, over ED, which is 8. because that's based on our proportions, right? So essentially all I did was I took these values here and plugged in what I knew. And that allows me now to solve for x. If I wanted to solve for x, you're still going to do your cross multiply and divide deal, but algebraically, like I showed you the other day, we're going to end up with 8x is equal to 24. Okay, if I divide both sides by 8, I get x is equal to 3. So that value right there, this should be 3 now, not x. Okay. If I want to go ahead and I wanted to use this form right here, if I wanted to use this form right here, do you think it's going to be any different? Well, let's take a look. So now I have AB, which we said was x, plus BC, okay, which is 6, over BC, which is 6, equals to AE, which is 4, plus ED, which is 8, over 8, right? So let's go ahead and simplify some of this that we can. Up here, 4 plus 8 becomes 12. And so now we're going to go ahead and cross multiply and do our algebra. Okay, so now we have 8 times x plus 6 is equal to 12 times 6, which we know is 72. If I go ahead and continue to solve this out, I'm going to have to distribute this 8, and I end up with 8x plus 48 equals 72. Subtract 48 from both sides, I'm going to end up with 8x is equal to 24. And if I divide both sides by 8, I'm going to move this up here so we can see it, I end up with x equals 3 again. So notice here the results are the same. Well, the results are the same simply because they're proportional, right? So what I did to this side here, I have to do to this side here. So what I did to this side, I have to do to this side because it's proportional. As long as I do the same things to both sides, you're going to maintain that proportion. Okay? So it makes sense that those answers come out to be the same. X is still a value of 3. Now, of course, not many people are going to do this over here. That's a lot of extra work. You're just going to stick to that. But it does prove to you that it works both ways. Okay? And again, if you have any questions, as always, please feel free to shoot me a message through misdgmail.com or msdgeometry@gmail.com, or just write it down and ask me in class. All right, let's talk about scale drawings and blueprints. We've already had exposure to this when I had you do the Halloween day, the Halloween projects, the zombie projects. I had you guys draw blueprints, and essentially what some of you might have noticed is that you drew it to scale. Now, I wasn't overly particular on you drawing and actually having a scale of 1 inch is equal to 12 feet or anything like that, but it's essentially the same thing. You took your picture, you took your zombie, which was life size, and you made it smaller and drew it on graph paper so that you could essentially show me a blueprint of that drawing. So essentially, scale drawings and blueprints are drawn to scale or proportion. So we take something huge and we make it small on a particular proportion. If you actually do a real blueprint or a real scale drawing, one of the things that you'll find out is that they are very specific. So like meaning that 1 inch is equal to 12 feet or something like that. It's not going to be just draw it smaller, label the sides, and call it a day. You actually have to have proportions so that when the builder builds it or whatever the case is, it's actually legitimate. Okay? All right, so let's take a look at an example of blueprints and scale drawings. This example actually comes out of your textbook. It says the Reunion Tower model is 10 inches tall. The actual tower is 560 feet tall. If the diameter of the model is 2.1 inches, what is the diameter of the actual tower? Okay, so we can simply set up a proportion. Okay, so here's what we can do. I know that the tower on the model is 10 inches tall. I know the actual height of the tower is 560 feet. Now, an easy way to set up proportions is to make sure that you have the same unit of measure in the same spot. So if I have inches on top and feet on bottom here, I need to go ahead and put inches on top over here, which actually gave me that value of 2.1 inches. So I need to figure out what x feet is. And so now we've set up our proportion that should help us determine what the actual diameter of the reunion tower ball is. Okay, so what I'm going to do is I'm going to come in here and I'm going to go ahead and cross multiply and set up my algebra problem. So I'm going to end up with 10x is equal to 1,176. If I go ahead and solve this, I'm going to divide both sides by 10. I'm going to have x is equal to 117.6. So the diameter, and that's feet now. Remember, because we were looking for feet here, that's what that is. That's feet. So the diameter of that reunion tower ball is feet, and you should be good to go with that. Okay, again, very simple proportion, nothing too terribly difficult about either one of these two sections. So again, go ahead and finish up these sections. Hopefully you're having a great break. We will grade 6-1 and 6-2 on Tuesday when you guys come back from the break. And again, leave me a quick comment on YouTube to let me know if you prefer this method, the way I'm writing all this out, versus the other method which I use on the computer. All right, if you have any questions, please let me know. Thanks.